In this lesson, we're going to learn how to rewrite exponents using radical notation, and sometimes you'll be able to simplify these. It depends on what the problem looks like. But to begin with, when we look at the exponents, they can be rewritten in radical form and vice versa. So in this case right here, if the exponent is 1/2, the radical is a square root. If the exponent is 1/3, then the radical is a cube root, with that 3 being in that radicand. If the exponent is a 1/4, then it's going to be a 4th root. If it's a 1/5, it's going to be a 5th root, and so on and so on. So in this case right here, when we use radical notation to rewrite each expression, and we see 64 to the 1/3 power, that's telling us we want to know what the cube root of 64 is, which it's asking the question, what times what times what gives you 64, which is a positive 4. In the next example, we have a fraction, but the 1/2 is saying, hey, we can rewrite this as a square root of 1/64. So we can take the square root of the numerator, so the square root of 1 is 1, and the square root of the denominator, which is going to be 8. And once we take that cube root or square root, if we are able to, then we're through with the radicand part of it. In this case, the next two examples look very similar. The difference is the parentheses. The 1/3 is saying take the cube root of all of this. It's incorporating all of that in the parentheses, which is 2m. Now, we cannot take the cube root of 2. There's no pretty number that's going to be the cube root of 2, and we can't take the cube root of m. So in that case, it won't be able to be simplified, so that is your final answer. Now, the difference between this example and this example is that cube root is only for the m, what's directly in front of it. So we would say the cube root of m, or rewrite it as the cube root of m. The 2 would just have to be on the exterior of that radicand. So there's a big difference if there's parentheses. In this case, we were taking the cube root of all of this. In this case, we're only taking the cube root of m. Now, in the next case, when we take the square root, we are only taking the square root of 64. If it were the negative 64, it would also be in parentheses. So in this case, we're taking the square root of 64. The negative sign would be outside of the radicand. So we would simplify this by saying the square root of 64 is 8, and that negative sign would just follow through. Now, some of these are going to have different types of exponents. And in this case right here, the difference is that your numerators for all three of these exponents are no longer 1. So we're going to have to rewrite these. And so the easiest way to do this is we're going to insert our own set of parentheses. We're going to split this exponent apart. We're going to take the top, the numerator, and put it on the outside. We're going to take the bottom, and we're going to put it on the inside. Now, when I put the bottom number on the inside, I'm going to put a 1 on top, because if you raise an exponent to an exponent, you multiply those. So 5 times 1 would be 5, and that 2 under that 1 that's really underneath that 5 is also going to be 2. So it's kind of like taking the top number out, leaving the bottom number on the inside, or you could do it vice versa. But in this case right here, it makes it simpler to what we just talked about. If it's a 1/2, we know it's a square root. So we're going to take the square root of 4, and we haven't done anything with that 5 yet. And the square root of 4 is actually going to be 2. And then we would say that 2 to the 5th power, 2 times 2 times 2 times 2 times 2, is actually going to give us 32 as a final answer. But it helps to rewrite these to begin with. Next example. Again, we do not have a 1 in our numerator, so we're going to have our negative 8. We're going to put our own set of parentheses. We're going to put the top number on the outside, the numerator on the inside with a 1 on top, because if we multiply that, we'd still have 4/3. Now, in this case, we're taking the cube root of negative 8. Those parentheses were there to begin with, so we're going to take the cube root of negative 8, and we're going to raise that to the 4th power. All we're doing is rewriting that fractional exponent as a radical. And the last thing we do is worry about that 4 as far as the exponent is concerned. If we take the odd root of a negative number, it is negative, and 2 times 2 times 2 is going to give us 8. Now we've raised the negative 2 to the 4th power, which means it's going to be a positive, and 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. So it's going to be a positive 16 as the final answer. Now, this next one, we have a variable involved. So we're going to rewrite this. We already have our x minus 4 in parentheses because there's 2 terms. So we're going to add our own set, take the numerator to the outside, denominator to the inside with the 1 on top. This is saying take the 4th root of x minus 4, so we're going to write it out, 4th root of x minus 4, and we're going to raise that to the 3rd power. Now, it is correct to leave it like this, or you may want to move, since we're not going to be able to take the 4th root of x minus 4, there's no such thing. In this case right here, you may want to just end up writing that highest exponent on the interior. This is saying the same exact thing. In the next example, set of examples, we've got to write these with positive exponents and then simplify, the same thing that we've been doing. Now, you cannot raise a number to a negative exponent, but to actually make that a positive, we would actually flip it over. Now, 64 is actually over 1, so when I flip this over, the 1 flips up, the 64 stays on the bottom. It doesn't change signs. The only thing that changes is when you move up and down within a fraction, it changes the exponent sign. But anything that occurs to 1 is still going to be 1. The rest of it's what we were just talking about, that we're going to let our bottom number be our root. You may just want to go ahead and get in the habit of writing it as the root, and then taking our top number and putting it on the exterior portion of that. But if you need to write an extra step down, that's fine also. So in this case, we're going to have the cube root of 64, which is what times what gives us 64, which is 4. We still have that 2 on the outside, so 4 squared is actually 16. Make sure you don't say 8. So it'll be 1/16. But the first step was make sure to make it a positive exponent, rewrite it as a radical, and then simplify that radical if possible. In this next case, same type problem. We're going to have a 1 on bottom. So when I flip this, I'm going to have the positive 1 on top. It's still going to be negative 8 on bottom, and it's going to become a positive 4/3. The negative does not change for the 8. The 4/3 does change sign. Only the exponent sign is actually affected. So when I rewrite this, because I have a number other than 1 in the numerator, I'm going to take the cube root. The bottom number is the root. So I'm going to take the cube root, and because negative 8 is in parentheses, we're going to put the negative 8 on the inside for the cube root, and then we're going to raise it to the 4th power. Now when I do that, the cube root of a negative number is a negative number. The cube root of 8 is actually 2, and we have to raise that to the 4th power. So 4 negative signs is going to be a positive, and 2 times 2 times 2 times 2 is going to give us 16. In our next example, we have a variable. And in this case, we're still going to have we need to write it as a positive exponent, so we're going to, it's still 1 understood 1 on bottom, so we're going to move it to the bottom. So we're going to have positive y, doesn't change the variable sign, only the exponent sign. So in radical notation, we would say that's the 6th root of y. Now the numerator is 1, so we don't have to write anything down for that. So in this case right here, actually you can write, because we cannot take the 6th root of y, you can actually either write it like this or you can write it like this. This meaning the same thing. This is simplified as it possibly can get. What you have to be careful of is in this next example. As far as the negative exponent is concerned, that negative 5/7 is only for the y. It would have to be in parentheses to be for the 3 or the 2 or affecting it in some other way. So in this case right here, what you have to be careful of, there is nothing wrong with a positive 2 on top, and there's nothing wrong with a positive 3 on bottom. All that we have to move up is that y to the positive 5/7. And if you want to rewrite this in radical form, then what you would actually do is take the 7th root of y to the 5th power. But you should be able to leave it either or, just because we can't simplify the 7th root of y to the 5th.